Alright, welcome back to Math and Beats. Today we're going to do another video on some mathematics. It's going to be a little demonstration on how to evaluate symbolic representations of functions. So let's get to it. First thing I'm going to do, remind you what the symbolic representation of a function is. It's when we write y equals f of x. X is the input of the function, y is the output, which is the result of applying f to x, the rule f. That's the rule specific to a situation. This came from the idea in which we thought of a function like a machine. Into the machine is some input, whatever it may be. We call it x as a placeholder. Then you apply some rule. What is the rule? F to the input changes into something else, and out spits the output from the machine, which we call y, which is also the result of applying f to x. So that's your little refresher on the symbolic representation of a function. We're going to make up a couple of examples right now and just evaluate some of these. So for our first example, we are going to make up the function, let's call it y, as the output is f of, let's use alpha here for fun. If you're unfamiliar with that variable, that's alpha. And notice I didn't use x, I chose to use alpha. I can call my input whatever symbol I prefer. It's just x is the traditional way of writing it. Let's let this function be, how about the negative cube root of alpha minus 2 times alpha. And we'll let alpha be any integer valued number. That is positive and negative whole numbers, including 0, the set of all the positive and negative whole numbers, including 0. All right, so that's what our alphas are, just to state it. So we're going to pick a couple of different alphas and just evaluate this function. How about if alpha is, say, 1? Then what we'd like to do is find f of 1, replacing alpha with the numerical value of 1. So in my function, I'm going to replace every alpha I see with 1. So I got negative cube root of 1 minus 2 times 1. The cube root of 1 is 1, since 1 times 1 times 1 is 1. So we got negative 1, negative times that cube root of 1, and then minus a 2. 2 times 1 is 2. Negative 1 minus 2 is negative 3. So we get that f of 1 here is negative 3. So there's one specific output for the input of 1. How about one more alpha? How about if alpha is negative 8? Then f of negative 8 is what we're trying to find. That's the negative cube root of negative 8 minus 2 times a negative 8. The cube root of negative 8 is negative 2, since negative 2 times negative 2 times negative 2 is negative 8. So we get negative 2. And then negative 2 times a minus 8 is a positive 16. This is positive 2 plus 16, which is 18. We get that f of negative 8 is 18. So a couple of evaluating examples for this specific function. All right, we're going to make up one more before we finish the video. Example 2 here. This time we're going to use a bunch of other symbols that we haven't seen so far. How about if we call the output this time w, and then we'll let our function rule be gamma, and our input be beta. So that symbol right there, that is beta. This symbol is gamma. And the output w, whatever that is. So here we're really trying to get across the point that we can call the input, the output, the rule, whatever we really prefer to call it. It doesn't matter. Traditionally, we call the input x, the output y, and the rule f. But in this example, we called the input beta. So up in our machine here, so okay, I'll just call the input beta if I want. I'll call the output W. In the rule, we can just say it's gamma in this scenario. So gamma applied to beta is some result we call W. Call it whatever you want, smiley face, whatever. So, having said that, we're going to make up a rule here. How about we call this half beta plus beta squared, maybe minus 3 times beta plus 1. So there's our function gamma of beta. And now we're going to pick a couple of different values to evaluate this at, just like the previous example. How about we pick beta is 2. Then we're trying to find gamma of 2. Plug in every beta with the value of 2. I get half times 2 plus 2 squared minus 3 times 2 plus 1, the quantity. Half times 2 is 1. 2 squared is 4. And then minus 3 times 3. 1 plus 4, 5. Minus 3 times 3 is 9. We get minus 4. Hence, the value of gamma of 2 is negative 4. One last one. How about beta is negative 3? Then gamma of negative 3 is 1/2 times negative 3 plus a negative 3 quantity squared minus 3 times a negative 3 plus 1. Replacing every beta I see with the value of negative 3. Half times negative 3 is negative 3/2. Negative 3 times negative 3 is positive 9. Minus a 3 times negative 3 plus 1 is negative 2. Remembering our order of operations, of course. Also, negative 3/2 is negative 1.5 if you prefer decimals. So here we got a negative 3/2 plus a 9, and then plus a 6. Negative 3 times negative 2 is positive 6. Negative 3/2, using associative property of addition, plus, we'll add the 9 and the 6 first, which is 15. And oh no, we got a fraction. Well, 15 as a fraction is the same as 30/2. So, negative 3 plus 30 is positive 27, and then all over 2. Hence, the value of gamma of negative 3 is 27/2. And there you have it. There's a little quick demonstration on evaluating symbolic representations of functions at various values. We saw we could substitute whatever variable or symbol we want for the input, the output, or the rule name. It doesn't matter what you call them, but the name of the game is, once you have the symbolic representation of the function and the actual rule, you simply replace every input value with whatever input you are given in a problem. And there you have it. So hopefully that helped. Hopefully you learned something. And now it's time to say goodbye. Please make sure you like the video and subscribe to the channel. Time for some beats. Peace.